We've seen two strategies to implement inheritance so far. The first one was the single table strategy, where all the objects were saved in a single table. The second was the table per class strategy, where every class had its own table. Now, the first strategy, the single table strategy, was the least normalized because all the columns of all the classes went into a single table, and there were many columns where the data was not applicable and it would carry null for most of the records. Now, the second strategy is slightly more normalized because we have a separate table per class, so there is no column which is quote unquote not applicable for a particular record. So this is slightly better, but then if you have a look at this, if you have a look at the tables here, let's say I query a four-wheeler. Now the four-wheeler has the vehicle ID and the vehicle name. Now the two-wheeler also has a vehicle ID and a vehicle name. That's because they have these columns inherited from the vehicle, which of course has the vehicle ID and the vehicle name. So these are columns that are repeating across different tables. So there is a way we can make this design slightly more better. Of course, it's a relative term, depends on the necessity, but this is another way we can do this, and this is by looking at the third type of inheritance strategy, and that is by using this one, the joined inheritance strategy. So again, there's nothing else that we need to do here. I'll just save this. So as long as you have all the three classes marked as entities, and you have the inheritance type as an inheritance strategy mentioned as inheritance type.joined, you're all set. So let's run this class. Again, to recap, I have three objects of the vehicle, two-wheeler, and the four-wheeler, and I'm saving all the three of them. So let's see how Hibernate creates the tables and passes these records. Okay, so let's look at the database so that it's more clear. Okay, now have a look at this. The vehicle table has the vehicle ID and the vehicle name, which is same as earlier, but interestingly it has data for the two-wheeler and the four-wheeler as well. Note that we had declared bike as a two-wheeler. It was an extension of the vehicle class, but it was a separate class. But what's happening here is the bike, which is a two-wheeler, is also inserted into the vehicle table. The Porsche, which was a four-wheeler, is also inserted to the vehicle table. Now what does the two-wheeler contain? Now the two-wheeler has the vehicle ID, and it has the property that is specific to the two-wheeler, which is the steering handle. Now the same way, the four-wheeler has the vehicle ID and the property that's specific to the four-wheeler, which was the steering wheel. So what's happening here is we are looking more at a join strategy. So in order to get all information from the four-wheeler, I need to look at the vehicle as well as the four-wheeler table. In order to get all information from the two-wheeler, I need to look at the vehicle and the two-wheeler table. So in order to pull up all the information for the four-wheeler, say, so all I need to do is I need to do a select star from vehicle join four-wheeler on vehicle dot, I think it is vehicle ID, but let's verify that. Okay, it's vehicle ID. On vehicle.vehicle ID equals four-wheeler dot vehicle ID. Now here you can see it's pulling up all the information that we need. So this is the complete information of the four-wheeler. So I have a bit of information in vehicle, and I have the rest of the information in the four-wheeler table. So what's happening here is it's in a much more normalized form than the table per class strategy we've seen earlier. So the data that has been inherited from the vehicle table does not go into the child tables. It remains in the parent table. So the vehicle ID and the vehicle name are going to be in the vehicle table no matter what the type of object is. So the bike, the two-wheeler object, the four-wheeler object, since they are inheriting from the same columns, the data goes to the vehicle table itself. And the way you can extract the data is by doing a join. Now the child class specific columns, the child class specific properties are going to go to the child class tables. Now, for example, say I have a few other columns defined here. So let's say I have a couple of other string or integer columns, properties defined here. Then what would happen is it would go to the two-wheeler table. So I would have more columns here, but then I would have just one reference to the vehicle ID. So this would be a foreign key. I would have just one reference to the vehicle table, and all the columns, that all the properties that have been inherited from the parent class would go as columns over here. So no matter what the object type, there would be a record here which would have all the inherited values. So I hope the difference is clear now. We have three strategies. One is the single table strategy, which puts everything into one table. Then we have the table per class strategy, which creates a separate table for each and every class, but then it duplicates the properties of the parent class that has been inherited. Now, so if 5 classes inherit from the same parent class, so all the properties of the parent class will be duplicated to each of those 5 tables. But in this strategy, which is the join strategy, what's happening is whatever properties are being inherited from the parent class, they will remain in the parent table. So the parent table will have the core properties which is inherited by each of the child classes, and the child classes will have tables for itself. So it is doing a table for each class, but then it has only the properties which are specific to the child class, and all the inherited values will remain in the parent class. And we will have to do a join in order to get all the data. So that's the reason why it's called a join strategy. So these are the 3 options we have, and you can choose what kind of inheritance strategy you want in your design depending on the need.